Hello, ladies and gentlemen. This is a video regarding the AP questions that are in the packet with the physics applications in it. So I'm going to show you how to do a couple of these questions so that you could resubmit some of them, or submit some rather, for homework. Okay, so let's begin here. So take a look at the question. It says here an object moves along the x-axis with a position of 2 at 0. The velocity of the object at t is greater than or equal to 0 is given by v of t. All right, we see it's a calculator question. So needless to say, you're supposed to put it into your calculator. So I already have that stored in here. And then the question wants to know in A, what is the acceleration of the object at t equals 4? So recall that acceleration is the derivative of velocity. So if I want to find it at 4, then the acceleration at 4 is going to equal v prime of 4. And since it's calculator, remember the calculator is going to do all the work for us. So what I'm going to do is I'm going to go to my calculator, go to the home screen. I'm going to do math 8. I'm going to do derivatives. The derivative of y1 at 4. And there we go. So we would say the acceleration of the particle is negative 0.52, and I'm going to round it 4. There is no units of measure, so I'm just going to leave the answer as is and move on to now the next part, which is B. So in B, it says, consider the statement the velocity of the object is decreasing. So for something to decrease, the derivative would need to be negative. So, well, what do we want to decrease? That would be the velocity. So I want to find out, essentially, is the velocity decreasing? Is the derivative of velocity negative? That's really what we're looking at. So I need to find out, is the derivative of the velocity negative on the interval from 3 to 4.5? Well, there's two ways of looking at this. You can either look at the calculator and see if that the v of t is actually decreasing, because remember, decreasing means the derivative is negative, or you could actually physically take the derivative of acceleration and see if it's located below the x-axis. Here, if I take a look at the graph, you'll see that the graph is decreasing from 3 to 4.5, and that's actually in line with what the statement is saying. So I would say that since v prime of t is less than 0 on the interval from 3 to 4.5, then statement 1 is correct. Okay, let's look at statement 2. Statement 2 says from 3 to 4.5, the speed of the object is increasing. So speed increasing. So if the speed is increasing, that's like saying speeding up. And if we're going to do speeding up, we need to look at two different things, acceleration and velocity. Well, we know from the previous one that if the derivative of the velocity is less than 0, that means the acceleration is going to be 0. We'll also notice, if you can recall, that in the graph, it's entirely below the x-axis. So the velocity is negative and the acceleration is negative. So with these two things, we know the answer to the question now. So is the particle speeding up? Well, remember that the velocity and the acceleration have to be the same sign for it to be speeding up, opposite signs if it's slowing down. So let's take a look. We know that the velocity is below the x-axis, so the velocity is negative. Slope is also negative, so we're going to say since the acceleration is less than 0 and the velocity is less than 0 on the interval from 3 to 4.5, then statement 2 is correct. Okay, so let's take a look at our next thing, C. So it wants to know, what is the total distance traveled over the object from 0 to 4? So remember, with total distance traveled, it has to be the integral of the absolute value of velocity. Do not use the initial condition. I saw that on the homework that a lot of students use the initial condition. This is not where we're going to be using total distance traveled. If you think about total distance traveled, your car has an odometer. It measures total distance traveled. And it really doesn't matter where the car went or the position of the car, it just reads a number. So if we want the total distance traveled, we're not going to account for the initial condition. Instead, what we're going to do is we're going to integrate my v of t function, but remember what we're going to do differently is we're going to integrate the absolute value of v of t. Without the absolute value bars, you'd just be finding the displacement, okay? So think about it that way. We're going to integrate from 0 to 4. And then again, remember, we're not going to use the initial condition. So on the calculator, here's what we're going to do. And it shut off. Okay, here we go. So I'm going to use Math 9. I'm going to do the integral from 0 to 4. I'm going to do the absolute value of my velocity. And I end up getting 2.387. So there's our answer. So 2.387. And that ends up being the total distance traveled. Okay, so we're all cool with that. So that's that one. All right, so let's take a look at D. D says, what is the position of the object when t is equal to 4? So we want to find the position of the object at 4. Well, how do we get position from velocity? We're going to have to work backwards, so we're going to use an integral. So we're going to integrate my v of t function to get back to position. But then you should ask yourself, wait a second, my position where I started actually matters. I didn't start at the origin, I started at t equals 2. So what I'm going to do in order to actually find my position at 4, what I need to do is I need to remember that I'm starting at 2 from the beginning. I didn't start at the origin. My a value ends up being 0 because that's where we started with. Okay, so we're starting at 0. And then here, this is going to be the b value where we're going to end in the problem. So it's going to go from 0 to 4. And that's going to get me in my position. And I just realized I created a linkage error because it's not x of t. It's specifically going to be x of 4. So I'm going to adjust that. Okay, so if I do that and I find on the calculator, here's what we're going to do. We're going to do 2 plus Math 9. We're going to do the integral from 0 to 4. We're going to do vars, function y1, and then enter. This is going to give me my position at t equals 4. So we get 3.432. All right. So let me just try to back up a little bit so you can see. Ooh, hello. Okay, let's see if we can do it that way. Again, it's the bad angle. I really can't do anything about that. I'm really sorry. But this is the work for the first question. All right, I'm going to stay tuned to the next video because that one's going to give you question number 12.